The other day I posted a video about how the sand at a lot of white sand beaches is parrotfish poop from like munching on corals and then pooping it out like sand. And then somebody commented, they were like, yeah, just wait till you find out what sea foam is. It's fish pee. Which like, no, not exactly. It's actually way more cool than that. And just so elegant and like circle of life, you know, like what you know what I'm saying? So, okay, what is it? It's like a latte. It's kind of how you make it. It's like a latte, lots of froth, lots of whip, okay? But it's a decaf latte. It's like decaf, but decay, because it's largely decaying organic matter, zooplankton, phytoplankton, algae, other dead stuff. Sometimes it's pollutants and things like that. Of course, you know, detergents and things, but most of the time it's just decaying organic matter, whatever is there in the area. And you notice this particularly after like large algal blooms and things like that, and the seasonality that appears to be connected to it. Anyway, so the point is, okay, so how do you get the big old piles of foam? Well, so when things break down, all their molecules are disassociated, floating around. And some of these proteins and lipids, like fats and oils and things, can become something called a surfactant. Okay, a surfactant. What a surfactant does is it reduces the surface tension of the water. Surface tension, that's a huge property of water. It's got a lot of surface tension. Okay, it's hard to break that surface tension. That's why things like water striders can just walk along the top. Okay, so so they basically, it makes the water loosey-goosey. So those really strong connections that the water has, particularly at the surface, you know, become a little bit more loosey-goosey. So when you're in a really dynamic environment like the ocean, all that going on, right? You can incorporate, and it's more loose, right? Now I'm incorporating a whole bunch of air and things. Yeah, bubble, toil and trouble. So then what's going on is, okay, so the surfactants, oftentimes they have if I put the picture, it might look vaguely familiar to you from like high school biology, like the phospholipid bilayer, the cell membrane of the cell, because it's actually kind of similar. So what happens is they have a hydrophilic head and a hydrophobic tail. So one side likes water, the other side not so much. You get enough of these molecules together and they're going to start to self-orient, okay? Those heads are going to line up like this, with all the tails pointing inside, away from the water, around that air that's been incorporated in. And after that happens, it forms something called a micelle, basically a cell, but it's just a bubble of air. And then you put a whole bunch of that together and you got a big old giant pile of sea foam, which some people call spume, and I do not like that at all. Spume? Like, what's wrong with you? No. But anyway, that's sea foam in a nutshell.